Today we're going to be working out a problem with factoring by grouping polynomials. Our equation is 20x cubed minus 48x squared minus 15x plus 36. Now the first thing we want to do is write it out in a simple form. This form is going to be ax cubed plus bx squared plus cx plus d. Now we're going to check and see if this is going to be able to be factored by grouping polynomials. A way to do that is to check and see if b divided by a is equal to d divided by c. This is why we wrote this general equation for our equation. We're going to be assigning each number their corresponding letter based on the equation. This will mean that a is equal to 20, b is equal to negative 48, c is equal to negative 15, and d is equal to 36. Now that we have all of our terms labeled, we are going to use that equation of b divided by a equals d divided by c. This means that we're going to write negative 48 divided by 20 as our b divided by a, and 36 divided by negative 15 as our d over c. Now when we divide these, we get 2.4 for both sides. This means that our equation is good to factor by grouping polynomials. To start by grouping our polynomials, we're going to split the equation into two parts. We're going to start with the left side by finding the greatest common factor. So for our left side, the equation reads 20x cubed minus 48x squared. The greatest common factor of that is 4x squared. So we're going to go ahead and write the 4x squared with parentheses where we'll put the remainder of the problem. Now for the right side, our greatest common factor is negative 3. So at the bottom, we're going to write negative 3 and then parentheses to finish the rest of the equation. Let's go back to our left side. We're going to divide each of the terms by 4x squared, which we saw was the greatest common factor. This leaves us with 5x minus 12. And on the right side, when we divide both terms by negative 3, we get 5x minus 12. We can see that both of the parentheses carry the same equation of 5x minus 12. So we're going to make a new parentheses and write this. This way we can group that off and then worry about our leftover terms. Our leftover terms are 4x squared minus 3. This is the equation once it is factored by grouping polynomials. Now we need to check and see if we have factored our equation properly. A great way to do this is by using a method called the FOIL method. The FOIL method stands for first, outer, inner, last. This is the order in which we'll multiply the terms. So we're going to start with the first two terms of each parentheses. This would be 5x times 4x squared. This is going to give us 20x cubed. Now you can see that our next step would usually be outer. This would be negative 3 times 5x, which is negative 15x. But we can also see that in the middle we have an x squared. And the result of doing the inner portion of the FOIL method would result in negative 48x squared. And if we're going back to that original format of ax cubed plus bx squared plus cx plus d, it would make sense to do the in first since we're going to get that x squared, and so it's a little easier and we don't have to swap them at the end. This is a common occurrence when using the FOIL method, so it's just something to keep an eye out for if you want to miss that little step. But if you do the outer before the inner or the inner before the outer, you can always fix it at the end. So in this case, to make it a little easier, we're going to do the inner first since it has that x squared term. When doing this, we see that we are multiplying negative 12 by 4x to get negative 48x squared. Then we're going to multiply 5x times negative 3 to get negative 15x, and negative 12 by negative 3 to get 36 for our final term. Now we can see that this matches up to our original equation, 20x cubed minus 48x squared minus 15x plus 36. Because the equations are equal, we can see that we properly factored this equation by grouping polynomials.